NASA has a program called Living with a Star, and within this program, NASA will launch the Solar Probe Plus mission. Partnering with the Harvard-Smithsonian Center for Astrophysics, we submitted a proposal for a suite of instruments to study the solar wind. In particular, at Marshall, we're going to develop grids that will be used as detectors in the Faraday cup that will be used to measure electrons, helium nuclei, and protons in the sun's solar wind. Direct funding to Marshall is $8.2 million, with another $3 million to the University of Alabama Huntsville for science operations. During the initial technology development phase of the mission, in particular that for the instruments, we will begin development of the detector system, and part of the Faraday cup detector system includes the need to be able to operate at high temperature. In fact, above 1500 C will be the nominal operational temperature for the instrument during the close approaches we will have with the sun's atmosphere. So the Faraday cup is the main instrument that Marshall will help test and fabricate. The full instrument team will also build electrostatic analyzers. We call them SPAN instruments. Those instruments will actually measure the electron, proton, and helium nuclei populations in the direction that the spacecraft is moving and in the anti-direction the spacecraft is moving. This mission is designed to study two important things about the sun. Why is the sun's atmosphere 1 million degrees while the sun's surface is only 5,000 degrees? And how does the sun produce a solar wind? To study these two things, the Solar Probe Plus mission will travel 80 million miles closer to the sun than Earth, 40 times closer to the sun than the planet Mercury. Within the sun's inner atmosphere, we will make measurements of the electrons and protons in the solar wind, and we believe we will discover the onset mechanisms for the solar wind and determine the mechanism heating the sun's atmosphere to millions of degrees. In answering these two most critical questions, Solar Probe Plus promises to rewrite the textbooks on solar astrophysics and provide us critical clues into stellar atmospheric formation and the evolution of stars.